Hello again, ladies and gentlemen. The next problem I'm going to do are the a, h, and k of old, back from chapter 4. Let's see the problem I have here. It says use the a, h, and k versions of x squared, x cubed, the absolute value of x, and the square root of x to find the function that has, well, I spelled something wrong there, that has the locator of vertex points at -2, 1 and passes through the point 3, 7. So nice easy way to start the problem is just to give yourself kind of a reference point, and then looks like that's my -2, +1, and then passing through 3, 7 somewhere up here. So you can imagine what an x squared, a parabola that opens up quite wide, an x cubed, one that opens up wide also, the absolute value of x, and the square root of x, and how each one of those functions would open up and touch, or at least start at and then touch one of those 2 points. So first things first, let's write down the y equals the x squared version, a times x minus h, quantity squared plus k. And we'll just do our x cubed while we're at it. Identical to the x squared, just we put a cubed up there instead. And then we've got the absolute value of x, which again looks very much like it. Well, we're going to make an absolute value. Notice no squared or cubed or anything, no exponents like we had up here and here, but just the absolute value function itself. And then the square root. You can see a fairly consistent form through each one of these. We've got our a, h, and k. H is attached to the x, k is on the outside, and a is just the one that's hanging out. Now on each one of these we've got the 5 letters, y, a, x, h, and k, but if you'll notice back up here, we had the locator point that was at -2, 1, so we'll just write -2, 1, and right below it write hk. And then we had the other point 3, 7 that it was passing through, so I'll just put xy. Now at this point I'm going to take each one of my 4 equations, 1, 2, 3, 4, and wherever I see an h, I'm going to put -2. Wherever I see a k, put +1. Wherever I see an x, I'm going to put 3. And then wherever I see y, put 7. So 7 equals a times x, which we said was 3, minus h, which is minus a -2 squared, plus k, which is +1. Continuing with the algebra on this, got 7 equals a times, well, let's see, 3 minus -2 would be 5 squared plus 1. Now we just got to work this equation a little bit. It doesn't like to focus very well. Work this equation a little bit, subtract 1 on both sides. So we get 6 equals a times 25, and then divide both sides by the 25. So our new equation looks like y equals 6 over 25 times x minus, and remember we said -2, so we're going to put +2 squared, and then +1 for that h value. And that's the equation of the parabola. It's going to open up and fit through that point. Our next equation, again, y, take out the a, take out the 3, put in that -2 cubed plus 1. Now this one's going to look the same because it's pretty much the same thing except for having 25, as in 5 squared, we're going to get 5 cubed in there. So 7 equals a times 5 cubed is 125 plus 1. Divide both sides, subtract off the 1. So we're going to get 6 equaling a times 125. Divide both sides by 125, so a equals 6 over 125 instead of the 6 over 25 like up there. X plus 2 cubed plus 1. Keep in mind that nothing's changed since when we first looked at this. When he said whenever you see inside the parentheses, you have to think opposite of the number that we started with. Had a -2, see the +2. So 7 equals a 3 minus -2 plus 1 relatively recurring theme here, and you see, or you're going to realize that, yeah, this really is pretty easy compared to, back when we first looked at it, it was a little bit difficult to do the math on it. So rewriting it, we got 7 equaling a times the absolute value of 5 plus 1. Going to subtract 1, 6 equals a times the absolute value of 5. Yeah, it's already positive, so we don't have to worry about changing the sign. So dividing both sides by 5, you get a equals 6/5. So y equals 6/5 absolute value of x minus h plus k. And there's our absolute value function. Then we've got y equals, which 7 equals a times the square root of 3 minus -2 plus 1. And then we're going to get the square root of 5, which won't be quite a pleasant number, but we can still use it in our denominator. 7 equals a root 5 plus 1. We'll subtract 1 from both sides. 6 equals a over the square root, or a times the square root of 5. Divide both sides by the root 5. And you guys remember how to rationalize the denominator, right? So we get 6 root 5 over 5 times, well, this should be a square root, not a parenthesis, square root of x plus 2 plus 1. That one does look kind of funny, but that's alright. Let's see, why don't we go back up here to our x squared term. What I'm going to do is I'm going to turn on the calculator, and I'm going to plug that into my calculator. I'm going to do parentheses, 6 divided by 25 So there's my a coefficient. We've got x plus 2, quantity squared, and then a plus 1. So once you got that function in there, what I'm going to do is I'm going to go into my table and take a look at it and see if -2 and 3 give me the same exact values that I had, from the beginning. And you can't see it very well. But there's a point in there right in the middle that says 3, 7 and -2, 1. So indeed it does have the vertex and the point that it's supposed to pass through. But that's the right way to check it, is just to go and plug it into the calculator and go to your table. Make sure your table itself has those 2 points, the locator point and the other point that it goes through. If it doesn't, then obviously something in our rewrite didn't work out so well. But just a matter of taking out the letters and plugging in the numbers.